I arrived in Silicon Valley in 1968. At that time, the MOS technology was still in its infancy. The major production, over 95% of production of integrated circuits was done with bipolar circuits. MOS were too slow and somewhat unreliable. There were already clear ideas of how to solve those two problems. We needed a lower threshold voltage technology and self-aligned gate to reduce the effect of the parasitic capacitances of the device. When I joined Fairchild, the R&D laboratory in Palo Alto, in February 1968, my first job was to devise a technology using silicon gate instead of metal gate. At that time, some experiments had been done before, but nobody had built transistors that were suitable for integration in an integrated circuit, neither at Bell Labs nor at other parts of the country. And nobody knew how to do that, how to do the first part of the process. So that's where I invented the tub. It was a way to make a cut in the initial oxide where the entire transistor was to be found. And with that, the problem was solved. And within 2 months, we had working self-aligned gate with silicon devices. They were also low threshold. The next step was to design a chip that could compare with a commercial chip using metal gate technology. The chip that was chosen was the Fairchild 3705 that was already in production. It was an 8-channel analog multiplexer with decoding logic that was difficult to make, particularly because the leakage current was too high and the on resistance was too high as well. Within 2 months, I did the design of the 3708, which is the silicon gate version of the 3705. And when we tested the results, we had chips that were 5 times faster than the 3705. They had 3 times less on resistance in their big switches. And in particular, the leakage current was reduced by more than a factor of 100. That was a great success and a great start. The 3708 was used also as a vehicle to improve the performance and the characteristics of the silicon gate technology. So along that line, we found that the amorphous silicon that had been used up to that point tended to break at oxide steps, and so we had to resort to using polysilicon. In other words, silicon that was deposited by vapor deposition of silane. And with that method, the coverage of the steps was improved tremendously, and we removed that obstacle. We also found that we could further reduce the leakage current and improve the reliability using a technology that was used from bipolar but could not be used for MOS devices. It was called phosphorus scattering, and that also improved the performance. I also found that I could make special type of contacts called Bury contacts, i.e. contacts directly from junction to polysilicon, an invention that I made early on in 1968, and I verified that it was working at that time. And also, at some time later, I developed a way to do the bootstrap load that was considered impossible to be done with the self-aligned gate because it was impossible to create an isolated capacitor. With that, the technology was second to none. It was ready for prime time. I joined Intel in April of 1970. My job was to lead the Pisa project. That was a 4-chip design, of which one was the world's first microprocessor. Nobody at Intel knew how to design such chips. In fact, a chip of that complexity had never been done before. So my first job was to design the methodology for random logic design that I was going to use for all 4 chips, though the beneficiary of that methodology was mostly the microprocessor. And within 11 months, we had the entire set of chips working. And at that point, it was very clear that the microprocessor was going to make a major difference in the market. I was instrumental in convincing the Intel management to get out from the exclusivity contract with Visicom and to introduce in the broader market the microprocessor, which was done in 1971, in November 1971. At that time, the 4004 had been in production for already 6 months. At that time, I was also leader of the 8008, which was the first 8-bit microprocessor in the world. That chip was introduced in April of 1972. And toward the end of 1971, I came up with the idea of doing a much better version of the 8008, which I call 8080. And it took me a while to convince management to allow me to design that chip. And eventually, 9 months later, I was able to start the project. And in early 1974, the 8080 was brought to market. That chip was the first high-performance microprocessor in the world. It had an instruction set of 2 microseconds. And really, what the other 2 chips suggested, the 8080 delivered. For the first time, we could have microprocessor used in a large range of applications. At the end of 1974, I started the company with one of my managers, Ralph Ungerman. The name of the company was Zilog. That was the first company entirely dedicated to the emergent microprocessor market. The first 2 products that I came up with were the Z80 CPU and the Z8 microcontroller. The 2 chips came out respectively in 76 and 78, and they were highly successful to the point that today they're still in high volume production. In 1982, I started Signet Technologies, a company that created an add-on to a personal computers that gave a PC the ability to do voice and data communications and creating an environment around communication and computing that was integrated, highly integrated. That company was sold 5 years later. And then I started another company called Synaptics that initially was dedicated to the development of neural networks using analog VLSI. In this manner, it was possible to emulate, not simulate, but emulate neural networks directly in silicon. It was too early, however, and so I decided to design touchpads and touchscreens, new inventions that had been extremely successful. And now Synaptics is a NASDAQ-quoted company, and it is a leader, world leader, in the human interface. Indeed, touchpad and touchscreens have changed the way we interface with our mobile devices. In 2003, I took over a company that was doing advanced imagers using CMOS technology. The company was called Foveon, And Faggin had a unique way to develop image sensors by stacking the 3 sensors in silicon directly. The company was sold in 2008, and from that point on, I decided to dedicate myself to the study of consciousness, a subject that had interested me since I was studying neuroscience back in the late 80s when I was involved with neural networks. In 2011, I started with my wife the Federico and Elvia Faggin Foundation for the scientific study of consciousness, and I'm busily working as much as I did work early on in my life, trying to understand and promoting the understanding through the foundation of the nature of consciousness. I'd like to thank the IEEE organization for honoring my work of so many years. I really appreciate. Thank you from the bottom of my heart.